So this talk is kind of two parts. The first are kind of the enhancements to NB, and I will say that all these enhancements, usually when I talk about enhancements, it'll be followed up by, and this will be in the next release that's in X number of days, weeks, months. A lot of this work is still exploratory, and I'll kind of try to point out what's been done, what's kind of in progress, and things I'm just still thinking about because I don't have a solution. There's not all figured out in my head. And and then the second part will be kind of the 64-bit impact, which that's been such a huge piece of what we've been doing for so long, which is finally kind of coming to a close. And so NB played there was a large impact as far as NB was concerned. So I'll talk a little bit about that. So NB is a lot of stuff, and there's books on it, there's articles. I really don't want to describe everything that NB is. I'll just say it's our source code and configuration management system for VA Smalltalk. It's been around a really long time, but I did want to draw kind of a high level view, just so I could point out the region that I'm going to be primarily focusing on, which is the region with the red dotted box. But essentially, we've got your client images, your client Smalltalk images, and that actually contains a portion of the NB suite, and that's the NB client. And so that knows how to basically take code, NB concepts. We've got, of course, method source and class definitions, but then there's other NB-ish like concepts, and it basically turns those into a kind of record, squishes them down into record formats. And there's two ways to interact with the underlining repository. The first way is kind of what would be familiar. I'm a big Git user myself because of the development work. We use Fogbuzz and Kiln has our Git stores, and so I'm on the command line all day doing Git commands. Actually, I was a big fan of Mercurial for a long time because I really liked the command line simplicity. And moving to Git was a little, it wasn't super difficult, but I'm not as big a fan of the Git, of the actual command line interface there, but I use it a lot. So I know those concepts, I know the NB concepts, and basically I would say the closest thing we've got is we can interact with the local NB repository, and we do have this concept of importing and exporting to remote or possibly local other repositories. So there is that kind of push-pull, but it's not exactly a clone. Like I know that this came from over here, or that it even matters. But there are some analogous concepts, but there are some big differences too. So it's kind of another way that people in the past have said NB's not really good at WAN development. So working in the large. And what they're primarily talking about is what's on the left side of the graph. They're talking about the picture is that you can also connect to a centralized repository through this kind of protocol. All these clients are connected to the same repository. And the tooling expects that to be highly consistent. So you click on something and you immediately see all the changes. So it would be analogous to every time somebody, you're working off GitHub, off that repository live. Everybody is, and the moment somebody makes some change up there, you're now seeing it in your client image. So you can imagine that in WAN, given the consistency level, that would be really hard to make that actually fast. So in fact, you can use it that way. But I'll give you an example. I live maybe 12 miles. I can't do that in kilometers, so I just double it or something like that. From my office, and sometimes I try to connect there to do small operations on the NB manager there. And so I'll actually do a connection, and it maybe will take 20-25 minutes just to connect my image to the repository. It works, but that's not a model people want to deal with, and that's certainly understandable. So more often than not, we even ourselves at Instantiations are kind of working locally, and then we kind of export to the main manager. But the problem with export or push is that we have to go through this this NB protocol, and we're back to the same problem that we've got, we've got this high latency, little tiny messages, and again, so a push would take 25 minutes for some small segment of code. So it wasn't really designed for that, and that's not really, in my opinion, a great model for it. I'd rather focus more on kind of what distributed version control systems of today would do, and try to create tooling and backend mechanisms to favor that. So I'm going to talk I'm not going to really focus on the protocol and highlight all that connection and consistency problems. I'm going to focus on the other side and look at backend data stores and what we've been trying to do. So as far as us at Instantiations, when we take, the good thing about the NB suite, which is really two things: Smalltalk, and then it's a library in C, several components written in C, and it's been around a really long time, and it's very, very stable. We haven't had any problems with it, and as we see, one issue though is it hasn't really seen any enhancements, and if we kind of reflect on why that is, there's a few different factors, such as this is a really high-risk thing to change. If you get this wrong, especially in a shared, kind of like ours, a shared repository, you've got lots of folks working on the same repository. If you get that piece wrong, you're going to be corrupting repositories that are team shared, and so this is a really high-risk area, and one that I've been taking a lot of time with. So I've been working with it for a year, and I'm still going, and I'm not going to release or do anything until I know it's ready. Now, it was C code written a long time ago by many different people, many different hands, and we saw the same thing in the video. It's trim documentation, lots of hands in it. It's really hard to reconstruct the picture of how this all kind of evolved, but some pieces of that are clear. But it's a very challenging code base. It's not a huge code base, but there's not a lot of design to it. It's just sort of like what we would probably expect from older C code. There's not a lot of modules or boundary places. It's just kind of like a lot of C code kind of all thrown in there, and it's just doing stuff. Some code duplication issues, some odd ones. I'll mention one I think you guys will find interesting, which is, we see duplication just because of kind of, I'm having trouble, with the dependency trail getting over to this section of code over here, so I'm just going to make a copy of it because it's easier or something like that. But this was different. This was so we have our own socket implementation inside the C program. That's because, again, we kind of want to keep this separate, this isolated from what's going on in Smalltalk. So, for example, if you were working with sockets in Smalltalk, you kind of don't want that to be part of your NB management, because you're going to corrupt the repository and somebody's going to be showing up at your door. So there's its own socket implementations, but there were 5 of them. And I couldn't figure out why. Why are there 5? And they all have the same interface. And I thought, why are there 5? And so I went and used tools like Meld and Linux or some sort of diff tool, and they would show up on the diff, and the first thing I do is look on the scroll bar and look at all the hits of diffs. And my first impression was, these are completely different files. And but then the closer I looked, the closer I saw, no, they're exactly the same file. It's just that variables are renamed. There's somebody preferred a space versus not a space here. Somebody inserted a logging statement, which I guess caused the next iteration of the socket. All these, but they were all semantically, if you dumped the instructions, they would be the same. They were the same thing, except for the logging statement, things like that. So that was a challenge. So I had to go through, for each one of these and kind of look at each of the 5 different implementations, which were all really the same implementation, and maybe create an extra parameter if somebody wanted to log or something like that. But that was interesting. So there was a lot of that going on. Again, I think it's many different hands. Nobody would just do that. I don't think any single person would just come up with that design. That wasn't around. We don't know the rationale, but it was an interesting type of code duplication. I don't think I've quite run across. And then finally, it's the type of testing. Again, maybe it predated, really strong test-driven development at the lower levels. So what we have we do have strong tests, but they're higher level, black box testing. We've got a lot of great inputs that we can feed in, and we can look at the outputs, and we can make sure that changes. We kind of know what we would expect to get, but we can't go in there and kind of make enhancements to the inner code base itself and kind of test it in isolation and do a lot of experimentation. So we do have this kind of strong testing on the outside, but there wasn't really any sort of testing on the inside. Therefore, many, many years, nobody wanted to touch it. Nobody wanted to look at it. It just worked, and that was kind of the end of the story. That being said, well, I probably should have put the last point first, and in general, at least my feeling is I don't typically like to fear the code base that we own and control. But that's just a personal kind of thing. That's not driven off need, which is what we would try to do as a company. So, but we still have things, we would like to do, like the pluggable backends. That actually just kind of came up because once the code was refactored and everything was modularized, that was kind of a natural consequence that just came there. And then it was more like, well, now what can we do with this, and what would we need to do for, say, Git support and this kind of things. John already talked about Unicode support in our product in VA, and so some of this will bleed down into NV. So that would be more like an immediate need, like I need to stop what I'm doing over here, and I need to just go address this, because that'll come up pretty quick once we get Unicode support. Another thing is the SSL TLS encryption. You might say, well, why is it worth it? I mean, if your WAN development's so bad, why would you even need to do that? But and so I would put it below. If that weren't the case, I would say that probably is, well, it should have been and is the top need. But given that it's more LAN, I would say it's still strong, and I think an option that needs to be there, but it's maybe not as critical as it would otherwise be. But it's still something, I think we should do internally. Provide better WAN support, so technically, as I said, you can connect over a WAN. I just wouldn't recommend it. And so now I just want to talk about, so I showed you the dotted red box, and that was kind of the source repository itself, the actual form. Because I'm going to start talking about the backend library pluggability, and this will lead to different types of storage models. And one of those maybe say Git, and then we can look at some mismatches. What would it take? So EM library right now, kind of the canonical, what it's always been, is a record-oriented repository, essentially. It's basically, on disk, it's just this gigantic single file that contains a header and a bunch of records that are all kind of chained. And that's all it is. And it just keeps getting bigger. Nothing disappears from it. And an NB record is simply, it's just a header followed with some size information and maybe some checksum and some other stuff. But essentially a size, because it's going to tell you how big the data is. It's variable length data, and it has the size and that. So typically, if you want to make a call to NB, it's going to ask, give me the record at this offset. Now give me the size. Now read the data, and it's always going to be kind of chunked up that way. So an example of a record would be class definition. So that would look one way. A method addition. Every time you touch a method, do anything at all, that creates a new addition record for you to reflect on. All right, I'm really sorry. I got to show you C code. I know it's been it's Friday. We're all tired. And this is what I'm going to do. I'm really sorry. But I think you'll maybe find it interesting for two reasons. The first is, and can you all see that reasonably well? Maybe you don't care, but I can actually make it a little bit bigger, I think. Oh, I have my scroll bar. I can make it bigger. I can't see it right here, then I don't do it. I can't. All right, well, I'm going to read what's necessary, but basically, here's two reasons why this is interesting. So this is the pluggable backend interface. And this was basically, after modularizing the system, this is what showed up. This was the backend, like here's the way that you represent the repository and interact with it on the backend. And so I abstracted it out, and this would be like in Smalltalk. Well, here's the two reasons why it's interesting. There's kind of a, first of all, this model for doing this pluggable backend stuff is from libgit. So if you ever looked at the implementation of libgit, and if you didn't already know, you can actually have multiple backends, multiple ways to store the Git repository. You can store it in a database or other mechanisms. And so this is the model that they use for that backend storage pluggability. And the other part is that doing it this way, you are in C. It's not an object-oriented language, but if you kind of blur your eyes and squint, you can see, kind of, I'm trying to get some properties of object-based, really, or really prototypical-based languages, but I'm not one, and I don't want to go way out of my way to appear like I'm one. So what can we do in between to get some favorable properties, but at the same time not make this something that it's not? And so what we see here is this is just a struct that is acting like an object. So we'll say in Smalltalk, we'll say you created an abstract class called VA Backend. That's kind of what this is trying to represent. So everything you see below are slots that hold functions. So if we were in Smalltalk, you could think of each one of those as an instance variable that subclasses will be putting blocks into. Think of it that way. And so these are all function slots, and these describe everything that you can do with an entity manager, with an actual, your back-end repository. And so you probably can't see it because I can't scroll, make it bigger, but we have the first section is your typical lifecycle stuff, open, close, create one if it's not there. There's reading records and writing records and reading bytes and writing bytes, and that's it. I mean, that's all this thing does. It's very trim at the end of the day. Now, if you looked at the original code base, you wouldn't know that because you would just see a lot of thousands and thousands of lines of C code that just have no boundaries to them at all. But this, once you summed it all up, this is what you have, and you see it's not that complicated. There's records and there's bytes, and that's about it. So this is a way to do, these are slots for functions. So think of this as like an abstract class. So the first thing it is says, okay, well, I need my first implementation. There was already one, obviously, so I need to translate this whole one big file with a header with a bunch of records chained together type of format. And so what I did is the first up at the top, that's your subclass. I created a new struct, EM library in the backend. And its very first field is the parent. So that's your abstract superclass. And being that it's on the first field like that, that means this thing can be either a pointer, it can be casted, and be treated just like a generic abstract backend. And that's kind of what we want, because everybody else, in every other module, we only want them to see the abstract version. We don't want them to know specifically what's under the hood. And so the second part is kind of the constructor where we're taking all those slots, the instance variables, and we're plugging blocks into them. Of course, they're not blocks, they're C functions, but it's the same concept that we're taking all of them, everything it is to read records or write records or bytes or anything to this specific type of repository. We're plugging in where can you go find these blocks of functions. So I said, okay, that's working, everything's great, we got great unit tests now, we can test this in isolation, we got great modularity, things are going well. So let's try another one. So I said, okay, well, I don't quite have the Git thing, have this, all in my head quite yet. In fact, I don't have how this, when we use other backends, what's missing, what are the pieces. And that's the nice thing about doing this way, it leads to more, as we all know, it's like a preaching fire. But this stuff has led, I'll just say reflectively, to more exploratory research. Whereas you couldn't do that before, it was just not possible. So I said, okay, so let me create this new subclass, a SQLite Backend. And you probably can't read what it says, but I added a little additional state because I wanted this stuff to be performant, so I added prepared statement handles for reads and writes and all that kind of stuff. And it's the same thing. Now I'm plugging in into those instance variable slots of blocks, I'm plugging in my own implementation specific to SQLite. All right, so you got it in SQLite. So what did it buy you? Well, in this implementation, this is where things started to become clear. What was needed was that essentially in the old version, where it's a big file with a header and everything in there, all those records, the keys are these file offsets. So whenever you read from this big repository, it's reading the keys going boom, 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 a bunch of seeks just all over the file. That's what it is. And so in this first version of SQLite, you actually can have a table with a key and a value where the key is, we call it numerical identifier or whatever, which is what it's historically been. And its value is still just binary stuff. And so, and the reason that is because the schema isn't down there, it's up in Smalltalk. You can't be, and this is by design. The low-level, indie stuff doesn't have any idea about Smalltalk. And that's because it used to store Smalltalk, it used to store Java, and it was made to be generic and not really care about what it was storing. So that's why it has that view of the world. I know records and I know bytes, and that's all I really know. And so that's problematic. First of all, from the DBMS standpoint, well, I can't create nice, relationalized tables because I don't know what this stuff is. It's just this opaque set of bytes. I have no way to interpret it. I have no knowledge of it. And it also represents a problem for Git because, okay, if you look at iceberg format, for example, you have method and file, and then you get source, and you have various other things. Well, there's no way for you to take this binary blob of stuff and deconstruct it into those elements. And so it was good to do this experimentation because that kind of clarified what you could maybe have guessed at as you were doing it, but it just sort of like, as you're trying to figure out where the issues are, this was very helpful. So as I say in the third point, you could do the same thing for Git, have a file of blob bytes, but why? What would that buy you? And there were some other things, so there's a whole record, and we don't have access to the schema down low, and we have elements of volatile metadata, which I think somebody brought up earlier about maybe the problem where you have something that the moment you open or do anything, there's just this change, but it's not anything you ever want to really version off every time. So in our world, it would be, we've got this concept of a library pointer, which is always kind of keeping track of where things are at the end, so you can do fast appends and that kind of stuff. And you imagine, well, at some point there may be just a valid impedance mismatch there. You might need to think about changing things. Or you could say, well, is there a way to represent that and get, let's say, the DBMS, I could see, solving that issue. So that's still some of the stuff that we're kind of considering. So as we do this third version, well, I'd like to redo the SQLite version because I'm now pushing the schema down further. And we explored, some people, I was prepared for, why don't you just push everything up into Smalltalk, and that goes back to this stuff was meant to work in isolation of what's going on in Smalltalk because of the safety issues. You're modifying code on shared team storage, or you could say it's your own local storage, so what if you mess it up? Well, so it's been thought about, and I guess still being considered, because it would be a lot easier to do that. All the information is already up in Smalltalk. So you push it down, you push it up. So we're still exploring that, and it's actually, it's fun to explore. As I said, there's no immediate needs that are driving, like Unicode will be an immediate need. And I'll have to stop some of this work and continue, but I do look forward to getting a solution for Git or basically anything else, because I do enjoy working with Git. I can set up VM stuff, and I think there is a mapping. It may not be one that involves zero change to the Smalltalk image where the client lives, but it could possibly be close. And really, we also need additional tooling to manage kind of this new model of if you move to like distributed version control models. So that's that piece. So that kind of concludes what's going on with the work, and so I would say the exploratory part there was still the pluggable backends, and the part that's been done though is the actual backend implementation for Envy, like the traditional one. That's done and everything's tested and it's looking really good, and it's much more of a pleasurable code base to work with. So now we can move forward with that. So now we'll switch topics just a little bit and go to 64-bit. And this was, make sure I'm cognizant of the time, good. This will just talk about some issues we ran into. You know, we did a 64-bit port of our virtual machine and environment, which was arguably just as large of a change. And so what did it mean for Envy, and why would we need that? Well, we need it because we have these shared libraries that allow you that connect, the Smalltalk image connects to talk to Envy repositories. So naturally, if you're in a 64-bit environment, those shared libraries need to be 64-bit libraries. And so, but as far as that C code goes, I've already kind of pseudo-bashed it as not very well organized, but and maybe this was just inherent that we're dealing with bytes, packed bytes, and stuff. But the switch over to 64-bit was simple. It was mostly just a recompile. There were only a few areas where you needed any change, and that's just good from a stability standpoint. I don't see a lot of issues that are going to be at that level. What's more interesting is what goes in the manager. So normally we think of your stock source code repository system, and you've got methods, source, class definitions, and maybe some other stuff. But in Envy, you can think of it as kind of a first-class database too of sorts, in that you can actually swap out your serialized objects. It's not really optimized as a database, say like Gemstone or something like that. It's not really intended for that at all. It's actually more about pushing settings. When you start the image, there's serialized settings just as objects, as tables, that just come back in, and you can read them off there and things like that. That's really kind of what it's for, and so you can just kind of swap objects in and out and do these kinds of things. Well, over the history of the Envy repository, you can imagine team environments, 32-bit. There's probably a lot of 32-bit serialized objects sitting in the Envy manager. Not only that, there are multiple different versions which gets managed. You can have older versions of the object, what it looked like once upon a time, and there's these transforms applied to them. It's terribly complicated. But the fact is, at the end of the day, the 64-bit guys who connect to these Envy repositories, the shared resource, have to be able to deal with that, and have to be able to deal with it in a way that means the 32-bit, the older 32-bit images can still connect up and read it just as they always have. So what we have is this translation engine, essentially. And what that means is the 64-bit virtual machine has a whole it's a rather large piece that deals with the understanding of 32-bit heap and object layouts and everything that would be involved with that, and basically how to convert that into the 64-bit equivalents. And so we use it in several different ways. The first is for our offline image converters. So if you have a 32-bit image on disk, then you can run this executable with that as input, and out it spits a 64-bit image. The second one is you can actually, and there's several use cases for this. We'll talk to you about one that we saw was maybe not safe, so we made a different design choice, which was you can launch a 32-bit image on a 64-bit VM, and it'll just on the fly convert. But the guy who wrote the piece was, as we were figuring out the complexity of the segments that we had and all the heap layouts, how these things work. He said, there's a possibility, unless we want to go through a lot more work, months and months, that this could be unsafe. And by unsafe, that usually means you're just running the image and all of a sudden you get a GPF or something and something pops up and you'll never know why. So we felt, that's another high-risk situation. It's not really worth it. We have a solution for offline, and okay, so you want to load up your image, fine, you just can't save it. But there's probably not a lot of use case for that, but that's okay. We have another solution, the preferred way to do that. But one place where we would do it is folks who created 32-bit reduced images, and they don't have, they don't have the capability necessarily to rebuild those. And so this is a mechanism that you can use, and it depends on what's going on in that 32-bit image, to actually be able to run that. If it's pure Smalltalk code, then it's going to be able to do it. If you've got your own library bindings, FF5 stuff, and you've described it in a way that is very much 32-bit, dependent, then there's very little it's going to be able to do. It's not going to be able to automatically fix that up for you. And the final thing is, when the 64-bit image now connects to the manager, and this is kind of the end of the story about how we solved this problem, was that we basically write, if we want to store a setting or read a setting, well, reading was always fine, we can translation engine. But now when we write it back out, we have to write it out in 32-bit. Which seems to make sense, because you have an older 32-bit image, it's got to look the same. He obviously can't read a 64-bit image, and he wouldn't know, or an object, and he wouldn't know why it doesn't work. It just seemed that I expect it to be this way, it's not GPF, and you're done. So, and we just, a lot of these issues, how they come up, how we figure them out, is really just, we just hit it one day, and we thought, oh gee, we got to handle this. Because there's just a lot of complexity in these. Another one that's interesting is bytecodes are stored in the NV manager. Bytecodes are stored in the source code repository system, which I thought was odd. And so what this allows, and it makes sense after the last bullet point here, number 4, it allows for distribution of code without source. And back in the day, this was kind of when third-party folks had kind of product add-ons to IBM at the time, Visual Age. This is a way they could distribute their product without supplying the source code necessarily. And maybe that's done today as well. I just don't hear a lot about it. I don't know who actually uses that. But we believe that's the primary use case of this. But it does cause issues because first of all, you just don't expect that to be the case, and it does change some code behavior in subtle ways. And so essentially what it does is when you're loading code from NV says, oh well, let me check first if I've got bytecodes at your version level. And if it says, oh, I do, then passes you over the bytecodes, and you never do a source compile. You just say, okay, I'm going to take these bytecodes and stick them in this compiled method, and you're done. And thankfully it's at the version level, because when we went to 64-bit, we essentially are using the same bytecode set, but it's, things are different, offsets, jumps, and things like that. So it's the same set, but different usages of them. And so essentially we bumped the version code, and that allows it to actually store them side by side if need be. Although personally I tend to turn off this feature because I don't really like it all that much. So here's the issue, is that, and some folks hit this during the beta because we were running betas, and they would launch, they would take code from their 32-bit manager, basically export it to another one. And they would open their new 9.0 beta 32-bit image up on it, and everything would load great. And maybe get some transcript entries saying unreferenced or undefined pool variable or something, something indicating that maybe not all the code is there or something's a little off or whatever. You can load it. You can load it just fine. But in the 64-bit, and the reason is because the bytecodes were cached. So it never actually compiled it. Had it compiled it, it would have said, this doesn't compile, so no. In the 64-bit now, he's never seen this code before. And so, and he asked Indy, I want to load this code, and he says, I don't have any bytecodes for your version level, so I guess you're just going to have to compile it. And then the 64-bit guy goes and compiles it and says, this is bad. It just halts and says, I can't do this. So we're getting folks saying, yeah, I think I roughly understand, it's not correct code, but it does load over here, but not, over here it's this compilation error. I just want you guys to be aware of that it is different. And that's the reason. All right, so that concludes my talk about that. I guess a little bit over, but anyway, you can. Here's some information about if you need to reach us. That's me at the bottom, Seth Berman. And so I hope, again, the Git stuff's really fascinating as I see here, and I like Git myself, so I do look forward to exploring that further, and hopefully getting Indy on Git. I think that would be really great. I'd like to work with that. So thank you very much. Questions? And then, yeah.
Not so much a question as a suggestion. You talked about the tension between pushing the knowledge of the semantics, pulling it up into Smalltalk in the image, or pushing it down into C.
Yeah.
And as I think you know, I am, to a first approximation, in favor of writing nothing in C and everything in Smalltalk. So I understand why you don't want to pull it up into the image, because then you could make changes there in the client that would just make it not work, and that's a bad situation. I suggest putting it all into a server that is written in Smalltalk.
Mm-hmm. Yeah, we've got. That's been an idea that's been proposed. So yeah, I mean, another piece that we don't, a lot of this is kind of like, I don't disagree with what you're saying. A lot of it is just sort of, it's always that tension of what can I do with, level of change, time on my part, and that kind of stuff. But it's a valid thing you bring up. It's actually been thought about, and I can't say disagree with it. I'm happy to explore it. I think it's a good idea.
Thanks.
Boris, do you have?
Yes. Not really a question, but just a statement.